Hello everyone, welcome to TechnoGate. So today we will discuss how to solve the recurrence relation. So recurrence relation solving method here. So there are three types of recurrence relation solving method here. First one is a substitution method. Second is the recursive tree method. And third one is the master method. So there are three methods to solve any recurrence relation: substitution, recursive tree method, and master method. Okay, so with the help of three methods we will solve any type of recurrence relation. Okay, so first of all, let's see substitution method. So there are a very important topic here. So there are one or two problem definitely will come from this topic. Okay, so substitution method is what? Here the given function is put again and again until the function is removed. Okay, so here what is substitute the given function again and again until the function is removed. Until the function is removed. Okay, so again and again, so until the given function is removed here. Okay, so let's take an example. So first of all we will see the substitution method, after recursive tree method, after that master method. So first one we will discuss the substitution method here. Okay, let's see. So like first problem is t of n minus 1 plus n. Okay, t of n equals to t of n minus 1 plus n here. So t of n is defined as t of n minus 1 plus n when n greater than 1 and 1 when n is equals to 1. Okay, so let's see this one. Okay, so let's check here how to solve this problem here. So suppose that here t like t 100 here. So what is the value of t 100 here? So according to this is one, t of 9 plus 10. Okay, then again same function. So at the place of this one substitute again this one. So what is this one? T of n minus 1 plus n. So t of n minus 1 8 plus n is what? 9 and remaining 10. Okay, next one is again put again and again. So here t of 7 plus 8 plus 9 plus 10 here. Okay, so every time it go to where t of 1 plus 2 plus 3 up to plus 10. So t of 1 is 1 here. Okay, so in this manner we will put this function here. So what is this here? T of n minus 2, okay, plus t of n minus 1 plus n here. Suppose that t of 10 is t of 9 plus 10 is then t of 8 n minus 2, 10 minus 2 8 here, n minus 1 9 here. So this is 9 and plus n here. Okay, same. So compare this one and with this one. So t of 8 plus 9 plus 10. Now next one is t of n minus 3 plus n minus 2 plus n minus 1 plus n. Okay. So suppose this is 10 times. If you use this 10 times here, okay, 10 times, then what will happen here? T of 10, n minus 10 plus n minus 9 plus n minus 8 plus n here. Okay. So up to here n here. But here how much time it will be put here? So this one tells about that how many times here. So here n minus 1 times here. So here n minus 1 times here. So put this n minus 1 time, then what will happen here? T of n minus 1 in same way plus n minus 2 plus n minus 3. Okay. And it goes to the plus n here, n time. So what will happen here? So here T of 1 plus this is 2 plus 3, okay, plus 4 up to this is plus n. So what is this here? So T of 1 is 1. So if n value is 1, then it is 1 here. So 1 plus 2 plus 3 up to plus n. So this is summation of first n natural number. So what is this here? n plus 1 by 2. So this recurrence relation, okay, gives this expression, what? This n into n plus 1 by 2 here. And this is the upper bound of order of n square here. So this one is upper bound on this one. So n into n is n square. So what is the time complexity for this recurrence relation is order of n square. They ask some time in like match the column. Okay, these are the 4 recurrence relations are there and 4 time complexity are there. So match the column problems will appear definitely. So here so n into n plus 1 by 2 is upper bound on order of n square. So what is the time complexity for this one? Order of n square. Okay. So let's see one more problem here and solve this, how to solve. So recurrence relation is like n is 1 then 1. If n greater than 1, then T of n minus 1 into n. This one. Okay. So let's check here. So T of n is T of n minus 1 into n here. Okay. Then same again, T of n minus 2, put this function again at the place of this one, into n minus 1 into n here. Okay. Now T of n minus 3 into n minus 2 into n minus 1 into n here. Okay. Next one is, so up to goes to the, again this function shows how many times here, n minus 1 times. So n minus 1 times, then it becomes T of n minus 1 plus n minus 2, sorry, multiplication here, into n minus 3 goes to the n. So what will happen here? T of 1 into 2 into 3 into n here. So here 1 into 2 into 3 goes to the n here. So here what here? So 1 into 2 into 3 into n is a factorial of a number. It's a factorial series here. So what is this here? Here is n factorial. It's n factorial here. 1 into 2 into 3 here. Okay. Because T of 1 is 1 here. T of 1 is 1 here. So it's n factorial here. And this is upper bound on order of n raised to power n. is upper bound on n raised to power n. So what is the time complexity for this one? Order of n raised to power n year. Order of n raised to power n year. Clear? This one. So in this way we can solve the recurrence relation here. So these are the very important. So some here I am solving some important recurrence relation. They appear directly in the gate examination here. Okay. So this is a order of n raised to power n here. Let's check next one is. So T of n is, if n is 1 then 1, if n greater than 1 then T of n minus 1 plus log n. T of n minus 1 plus log n here. Okay. So let's check here. So T of n is what? T of n minus 1 plus log n. Okay. So solve this one. So again same is a substitution method. So through a substitution method we can solve any recurrence relation. Any recurrence relation here. Okay. So here T of n minus 2 plus log n minus 1 plus log n. Okay. So put this equation at the place of again. So here n minus 2, here log n minus 1 plus log n here. Again is a T of n minus 3 plus log n minus 2 plus log n minus 1 plus log n here. So it go to the n minus 1 time here. So n minus 1 time, then what will happen? T of n minus 1 plus log of n minus 2 plus log of n minus 3 plus log n. Okay. So what will happen here? This is T of 1 plus here log 2 plus log 3 plus log 4 here plus log n. So here 1 plus log of 2 into, so here log a plus log b, what will happen? So log a plus log b is what? Log ab. Log ab here. So 2 into 3 into 4 into this one. 2 into 3 into like this one. Okay. So log 2 into 3 into 4 into, and we can write like 1 plus log of 1 into 2 into 3 into 4 into n here. So here log, this is log series here. So what here is n factorial, and we know n factorial is what? Upper bound on log of n raised to power n here. So what is the time complexity here? Order of n log n. Order of n log n here. Okay. So what is the time complexity for this recurrence relation here? Here n log n here. Okay. This is the n log n line. Clear? Let's take another problem. So let's say what is the problem here. So if n is 1, then 1 here, right? T of n minus 1 plus 1 by n. This one. If n more than 1 here. Okay. So let's check this one. So here what T of n is T of n minus 1 plus 1 by n here. Okay. So here again put the substitution method, then again put this one again, T of n minus 2 plus 1 upon n minus 1 plus 1 by n. Again t of n minus 3 plus 1 upon n minus 2 plus 1 upon n minus 1 plus 1 by n. Okay, so every time we substitute the same function again and again. So n minus 1 times n minus 1 time here, then what will happen here? T of n minus 1 plus 1 upon n minus 2 plus 1 upon n minus 3 up to it go to the plus 1 by n here. Okay, this one here. So what is there here? So t of 1 here 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up to plus 1 by n. So this is what here. So t of 1 is 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up to plus 1 by n. Okay. So here what is this? This is a log series. Okay. This is the log series here. So is a upper bound on order of log n. Upper bound on order of log n. So what is the time complexity here? Order of log n. Okay. Okay, so base here base is not same, so there is no use of log series here, but is upper bound on log n. Okay, let's see another problem here. So here like t of n by 2 plus c here. So this is a recurrence relation for binary search here. So let's see how to design the recurrence relation through binary search. So let's see what is the time complexity here. So t of n is t of n by 2 plus c here. T of n by 2 plus c here. Okay. So let's check here. So put t of n by 2 square here. So put n by 2 plus c again and again plus n by 2. Okay, sorry, c plus c here. So put n by 2 at the place of n here, n by 2 square plus c here. Again t of n by 2 cube plus c here. Okay, and suppose it's k times, then what will happen? T of n by 2k plus here 3c there. Okay, this is the 3c here. K time means this is kc here. So here power 3, then this is what? Kc. Okay, so your aim is you want to make this term 1 here. Okay, so always assume n equals to 2 raised to power k. N equals to 2 raised to power k here. Okay, so log n, take log both of the side, then k. So k equals to log n here. Okay, so whenever you see the division, the recurrence relation, always assume n equals to 2 raised to power k, because your target is make it 1 here. So whenever it is 1, then it 1 here. So what will happen here? T of 1 plus, so k is what? Log n. N2 here separately c here. So t of 1 is 1 plus c dot log n. So it is upper bound on what? Order of log n here. Higher order term here. See, constant never matter here. So here log n. So time complexity of binary search is what? Log n here. Time complexity of binary search is what? Log n here. Okay. So if the division, we see the division in the recurrence relation, this is the way to solve it. This is the way to solve it. Okay. Let's take another problem with the division. So let's take if n equals to 1 year, then 1 year, otherwise 2tn by 2 plus n if n greater than 1. If n greater than 1 year, so let's check here. T of n is 2tn by 2 plus n year. Okay, so this is a recurrence relation for merge short in all three cases and quick short best case. So we will discuss in the merge short and quick short. So here what will happen here? So 2 put again and again here. So 2t n by 2 square plus n by 2 plus n here. So put again and again this function. So here 2 here, then 2tn by 2. So this becomes n by 2 square plus n by 2 and n is separately here. So what will happen here is a 2 square t n by 2 square plus n here. So what will happen? What is this here? So this is 2 square n by 2 square plus 2n. Okay, clear? Because 2 into n by 2 cancel out here. So suppose again put, then what will happen? 2 cube t n by 2 cube plus 3n. Okay, this is a 3n here. Now suppose goes to the k times. Okay, k times, then what will happen? K times 4, 2 raised to power k t n by 2k plus k dot n here. Okay, k dot n here. So again always assume, so whenever you see the division, always assume what? Assume n equals to 2 raised to power k here. So take log both of the side, log n is k here. So here n, so n equals 2, so this becomes n t of 1 year plus k is what? Log n, okay, into n here. So what here? N plus n log n here. So which is upper bound here? Order of, so here n and n log n, what is n log n? So this is a time complexity of merge short is what? Order of n log n here. Okay, and quick short best case order of n log n here. So whenever you see the division, then always assume n equals to 2 raised to power k, because your m is make it 1 year. So if n is 1, then it returns from here. Okay, let's see another example. So here 2tn by 2 plus 2. Okay, so let's see what will happen. So here 2 here. So let's check here. So 2t n by 2 plus 2 and plus 2 here. Okay, put this function again here. So at the place of t here. So here 2 square t n by, this n by 2 square, n by 2 square plus 2 square plus 2 here. Okay, the third time we will put then 2 cube t n by 2 cube plus 2 cube plus 2 square plus 2 raised to power 1 here. So is k times goes to the k times here. Then what will happen here? Is k times here, then 2 raised to power k t of 2 raised to power k plus here 2 raised to power k plus 2 raised to power k minus 1 up to this goes to the 2 raised to power 1 here. Okay, so again assume, so always assume n equals to 2 raised to power k. Okay, so here what will happen here? So this is the n, It's a t of 1 here plus, now this is a geometric series. This geometric series starts with 1 here. So 2 raised to power 1 plus 2 raised to power 2, it goes to the 2 raised to power k here. So here n, t of 1 is 1, so here 1 n only plus. So here, what is the summation of geometric series? A Rn minus 1 upon R minus 1. A into R raised to power n minus 1 upon R minus 1. So A is the first term. What first term here? 2 here. R is what here? Okay. First term is 2 here. Our common ratio is 2 here. Okay. Common ratio means second term divided by first term here. And total term k here. Last term. N is the last term. Last term n minus 1 upon 2 minus 1. This. So what will happen? N plus 2 raised to power k minus 1. Okay. So 2 raised to power k is what? N here. So n plus 2 n minus 1. So this is the n plus 2n minus 2. So this is a 3n minus 2. Then this is a upper bound on n. Okay. So this is upper bound. So 3n higher order term is n here. So this is the way to how to solve the recurrence relation. So directly you can match the following problem. Okay. Some of the recurrence relation, some of the time complexity only match. So directly you can see that this problem directly appear in the gate examination here. Okay. So whenever the division, always assume n equals to 2 raised to power k here. So time complexity for this is this upper bound on order of n. Clear? Let's check another one. So here t of n is n equals to 1 then 1 and then 8tn by 2 plus n square if n greater than 1. Okay, let's check here. So t of n is 8t n by 2 plus n square here. Okay. So this is substitute method here 8t n by 2 square plus n by 2 square, okay, and plus n square here. So it becomes 8 square t n by 2 square plus, so here 8 into, okay, multiply n square by 4 here. So what is 2n square? So 2n square here plus n square here. Okay, this one. Next time is what? 8 cube t n by 2 cube plus, this is what? 2 square n square plus 2n square plus n square. Okay. So it goes to the k times here. K times. Then what will happen here? 8 raised to power k t n by 2 raised to power k plus. So here n square is common here. N square is common here. So here what? This is the k. So here k is 3 here, but here there is 2 square. So is n square is common here. So here 3, here maximum power is 2. Here 2 maximum power is 1 here. So is it k minus 1. So 2 raised to power k minus 1 plus 2 raised to power k minus 2 and goes to the 2 raised to power 0. Because you can see right like 2 raised to power 0 also. 1 also. From 0 to k minus 1 here. So it becomes here. What it becomes here? So 8k. So assume n equals to 2 raised to power k here. So what it becomes here? 8 cube is n cube. N cube plus here this is 1 also, 1 value is 1 here. Okay. So plus n square is common here. So this is a geometric series. 2 raised to power 0 plus 2 raised to power 1 up to plus 2 raised to power k minus 1 here. So what is the summation of geometric series? N cube plus n square. First term is what? 1. Common ratio is what? 2. Last term is k minus 1. Okay. Last term is k minus 1 plus 1. Why plus 1 here added q? Because n minus 1. Okay. So because it started with 0. So this series starts with 0. That's the reason we add the extra term 1. Minus 1 upon k minus 1. Sorry, 2 minus 1. R minus 1. So last term is k minus 1. This is k minus 1 and plus 1 because this series starts with 0. That's the reason we added 1 here. So here n cube plus n square and this is 2. So 2 raised to power k here minus 1 upon 1 here. So what is upon here? So 2 cube is again n here. So n cube plus n square 2 cube n minus 1 here. So here n cube plus n cube minus n square. So it is a 2n cube minus n square. So upper bound on n cube here. Upper bound on n cube. So higher order term is n cube here. So what is the time complexity of this is n cube here. Okay, n cube here. So here this is the recurrence relation for matrix multiplication. We will discuss in the next lecture how to design the recurrence relation. So this is a recurrence for matrix multiplication, and you know the in matrix multiplication we using 3 for loops. So what is the time complexity of 3 nested for loops? N cube here. So order of n cube. So this is the way in which way we can solve the recurrence relation. Okay, these are the some important recurrence relations are there, and many more recurrence relation we will solve through the recursive tree method and master method. So this is the first method, is a substitution method. Okay, so we will discuss next remaining 2 in the next upcoming lecture. Okay, thank you everyone.